Olá, pessoal! Tudo bem? Sejam muito bem-vindas e bem-vindas ao Inglês de Verdade. No vídeo de hoje, você vai encarar um desafio rápido e poderoso de listening em inglês. Você vai ouvir um pequeno podcast em inglês e logo depois responder 5 perguntas para testar se realmente entendeu o que foi dito. Com esse exercício, você não só treina o ouvido, mas também aprende novas palavras e expressões em inglês de forma natural, como acontece na vida real. E olha só, se achar necessário, pode ativar a legenda em inglês disponível aqui no vídeo para te ajudar no processo. Então, concentre-se, ajuste o volume e vamos começar agora!
If you had to name the most extreme, mind-bending object in the entire universe, what would you even pick?
That's a great question.
I mean, forget nebulas or, distant galaxies. We're talking about places where reality itself just sort of breaks.
Places so dark that not even light, the fastest thing we know, can get away.
Exactly. We're doing a deep dive into black holes today. The universe's ultimate mystery, really.
And it's funny, for so much of the 20th century, they were just mathematical quirks, little oddities that popped out of Einstein's equations.
Right, like a fun little thought experiment for physicists. But
Yeah.
now they're real, undeniably real.
Oh, absolutely. We have pictures now. We study them. They're at the center of some of the biggest questions in all of science.
And that's our mission today. We want to unpack the most surprising and maybe a little terrifying facts about them to show you the real physics behind the sci-fi reputation.
And the key thing to remember, the idea we'll keep coming back to, is that all of this stuff, as wild as it sounds, comes from our best theory of gravity.
Albert Einstein's theory of general relativity.
Exactly. The theory that says matter actually warps space and time, and if you get enough matter in a small enough space, that warp becomes, well, infinite.
Okay, so let's start at the beginning. To understand the monster, you have to understand its birth, right? Where did it come from?
They're born from the deaths of giants. We're talking about absolutely massive stars, 10, 20, maybe even more times bigger than our own sun.
And for most of their lives, millions or billions of years, these stars are in a kind of perfect balance.
It's a cosmic tug of war, really. You got gravity, this immense force trying to crush the star inwards.
Pulling everything toward the center.
Right. And pushing back against that, you have the incredible energy from nuclear fusion in the core. It's like a constant controlled explosion pushing outwards.
So that outward pressure from the fusion keeps the star from collapsing under its own weight.
For as long as it has fuel, yes. But like any engine, it eventually runs out.
And when the fuel is gone,
that outward push just stops almost instantly. And gravity, which has been there the whole time, finally wins.
And it wins in a big way, I take it.
A huge way. The star implodes, the outer layers crash into the core, and then rebound in this massive explosion, a supernova.
Which can outshine an entire galaxy for a short time.
For a while, yeah. But what's left behind, the core, that's what matters for our story. If that core is heavy enough...
Heavier than a certain limit.
Exactly. Then there is no force in the universe that we know of that can stop the collapse. Gravity just keeps crushing it, squeezing all that mass into a smaller and smaller and smaller space.
Until it becomes a point, a singularity.
A point with basically zero volume and infinite density.
That's a concept that's almost impossible to really wrap your head around. But what does that density mean in practical terms? Can you give us a scale for that?
Well, let's just say if you could somehow scoop up a tiny piece of this material, say the size of a sugar cube, right before it becomes a singularity.
Okay.
That little cube would weigh billions of tons.
Billions? That's just staggering.
And all that density, all that gravity, creates the black hole's most famous feature, the event horizon.
The point of no return.
The point of no return. It's this invisible boundary where the gravitational pull is so strong that the speed you'd need to escape is faster than the speed of light.
And since nothing can go faster than light?
Nothing gets out. Not matter, not energy, not even information. Once you cross that line, you are cut off from our universe forever.
This is where the physics gets really strange, almost philosophical. Because what happens when you cross that line depends entirely on who's watching.
It's the ultimate test of general relativity. So for the person falling in as they cross the event horizon, they might not even notice.
Really? No big sign or barrier?
Nope. To them, everything feels pretty normal, for a little while at least.
But what about me? If I'm watching safely from a distance through a telescope, what do I see?
Now that's where it gets weird. From your perspective, because of the extreme gravity warping time, you'd see your friends start to slow down as they got closer to the edge.
Slow down.
Slower and slower. Their light would get redder and dimmer until right at the boundary they would just seem to freeze.
Frozen in time.
To you, yes.
Right.
It would look like they're just hovering there at the edge forever. You never actually see them cross.
So time literally stops for them, from my point of view.
It highlights just how relative time is, and this isn't just a theory. This effect, time dilation, we have to account for it every day with things like GPS satellites.
Right, but this is that same effect taken to the absolute extreme.
The ultimate extreme.
Okay, speaking of extremes, let's talk about the less pleasant side of things, the actual fate of anything that falls in. I'm talking about spaghettification.
It is a very descriptive term, isn't it?
It is. So what is it?
It's all about tidal forces, but on a completely different scale from what we experience on Earth.
Okay, so tidal forces, like how the moon's gravity pulls on Earth oceans and creates the tides.
Exactly. It's about the difference in gravitational pull over a distance. But near a black hole, that difference, that gradient, is incredibly steep. Meaning, if you were falling in feet first, the gravitational pull on your feet would be exponentially stronger than the pull on your head, just a few feet away.
So your feet are being pulled much, much harder than your head is.
So much harder that the force would literally stretch you. It would overcome the forces holding your own body together.
They'll pull you apart.
It would pull you apart, stretching you into a long, thin strand of atoms. Like a piece of spaghetti, it's a complete and total unraveling of matter.
It is a horrifying thought. Let's maybe bring this a little closer to home. We don't have to look light years away to find one of these, do we? There's one right in our own backyard, cosmically speaking.
There is. Right at the heart of our Milky Way galaxy, there is a supermassive black hole named Sagittarius A, SGRA star for short.
And when you say supermassive, you really mean it.
Oh yeah, we're talking about something with the mass of more than 4 million of our suns.
4 million. And it's the anchor of our galaxy.
It is. Its gravity is what orchestrates the dance of billions of stars in the galactic center. We can't see the black hole itself, of course.
But we can see its effect.
We can. We've tracked stars orbiting it for decades. There's one star, S2, that whips around it in just 16 years. It's moving at insane speeds.
And the only way to explain that orbit is if there's something incredibly massive and invisible right there.
It's the smoking gun. And what's interesting is that, for all its power, SGRA is actually pretty quiet right now.
It's not eating much.
No, it's mostly dormant. Just snacking here and there. And of course, the fact we can even talk about seeing them is amazing. The first actual image of a black hole's shadow only came out in 2019.
A huge achievement. Which brings us to a really important point, a big misconception people have. The idea that black holes are like cosmic vacuum cleaners.
Right, that they're just roaming around space, sucking everything up. That's
Yeah.
just not how gravity works. A black hole's gravity is powerful, but only if you get really, really close. From far away, it behaves just like any other object of the same mass.
So let's do a thought experiment to make that crystal clear. If our sun, right now, was instantly replaced by a black hole with the exact same mass, what would happen to Earth?
In terms of our orbit, absolutely nothing.
Okay.
We'd keep going around it just like we do now. Now, we would freeze to death in total darkness, of course.
Of course. A pretty big downside.
Major downside. But we wouldn't get sucked in. The danger is local. It's all about crossing that threshold.
Okay, so we've talked about how they're born, how they bend time, how they rip things apart. That leaves the biggest question of all.
Yeah.
The ultimate mystery.
What happens inside?
What happens inside the event horizon?
And this is where science hits a wall, a very real wall. At the singularity, that point of infinite density, our laws of physics just break down.
What do you mean they break down?
The equations we use to describe the universe, general relativity for the big stuff, and quantum mechanics for the small stuff, they just stop making sense. They
Yeah.
give us answers like infinity, which is basically physics speak for we have no idea.
It's where the two biggest theories in physics crash into each other.
And that crash leads to these huge, profound questions, like the information paradox. Does a black hole destroy information forever? Because our laws say that shouldn't be possible.
And what about time? Does it keep going inside? Does it even mean anything anymore once you're in there?
And then there's the really wild speculative stuff. Are they gateways, wormholes to another part of the universe, or even another universe entirely?
That's purely theoretical at this point, though.
Highly speculative. But what black holes do is they force us to confront the fact that our theories are incomplete. They're like a cosmic laboratory, pushing us to find a new, better theory, a theory of everything.
And I think that's why they're so fascinating. It's not just that they're big and scary, it's that they represent the very edge of what we know.
Exactly. They show us how far we've come, but they also hold up this giant sign that just says, you don't have all the answers yet.
They prove that the universe is always stranger than we can imagine. So let's leave you with a final thought on all this. If the laws of physics that we use to explain everything, from planets orbiting to light bending, if they completely fail inside a black hole, does that mean that to truly understand the universe, we need a whole new set of rules? What else is hiding out there in the dark, just waiting for us to rethink everything we thought we knew?
E aí, como foi o desafio? Quantas perguntas você conseguiu acertar? Independentemente do resultado, o mais importante é que você treinou seu listening em inglês, entrou em contato com novas palavras e deu mais um passo no seu aprendizado. Lembre-se, quanto mais você se expõe ao inglês real, mais natural ele se torna. Se esse exercício te ajudou, deixe o like, compartilhe com alguém que também está estudando inglês e se inscreva no canal Inglês de Verdade para não perder os próximos desafios de listening. Ah, e conta aqui nos comentários, quantas você acertou? Nos vemos no próximo vídeo. Até mais e continue praticando inglês de verdade.
E se você assistiu até aqui e quer aprender inglês sem gastar um centavo durante todo o processo de aprendizagem, com acesso a ferramentas, atalhos e mentoria que vai fazer com que você absorva o inglês de forma rápida e natural, eu te convido a conhecer o método dos 9 passos para a fluência, onde você vai conhecer a forma correta de aprender o inglês.
Good. Now we can go in the water.
Com acesso a ferramentas que irão te auxiliar nesse aprendizado. E o melhor, todas encontradas de forma gratuita. E entre essas ferramentas, uma você usará para manter contato com nativos do inglês para que sua prática de conversação seja mais eficaz. Porque nada melhor do que absorver o inglês diretamente da fonte. E quando eu digo que essas ferramentas são gratuitas, eu não quero dizer que apenas o primeiro mês será grátis, como degustação, e que se você quiser continuar usando, você terá que pagar. Todas as ferramentas que serão apresentadas a você nesse método são gratuitas para o resto da vida, até quando você quiser usar. Esse método é perfeito para você que não tem ideia de como e por onde começar e para você que já tem um conhecimento em inglês, mas ainda não conquistou a fluência. Nele você será apresentado a atalhos que vão acelerar seu aprendizado que estudantes que estão começando não fazem ideia que existem. 99% das pessoas que colocarem esse método em prática, seguindo passo a passo, conseguirão realizar seu sonho de se tornar fluente em inglês. Então, se você acha que finalmente chegou a hora de realizar seu sonho e dominar de vez o inglês, clique no primeiro link da descrição, que eu tenho certeza que você não vai se arrepender.